All right, our next presenter is Valerie Huff. Valerie is a senior civil engineer with Wallace Group with a focus on all things water. She has a broad range of general civil engineering experience, including street improvement plans, grading plans, utility design, preparation of technical specifications, and construction management. Valerie specializes in analysis and design of stormwater, water, and sewer systems. She has prepared drainage and infrastructure master plans, performed hydrology and hydraulic studies, as well as design of low-impact development plans and specifications. Valerie is a leader in the area of stormwater quality and post-construction compliance and has served on both the San Luis Obispo Countywide Hydro Modification Advisory Committee and the Central Coast Regional Water Quality Control Board's Joint Effort Review Committee. Valerie is a graduate of Cal Poly San Luis Obispo with her master's in water resources. Please welcome Valerie.
Thank you, Liz. Thank you for having me here today. I'm going to be talking about pervious concrete, and pervious concrete is a structural stormwater control measure that can be used to retain water on site to meet your post-construction requirement for that on-site infiltration. And so what I'll be talking about today is a brief overview of what pervious concrete is and how it's different from your standard traditional concrete. We'll be going through your construction methods, which are very different than standard concrete. We'll be talking about considerations for inspection, going through some details for specifications, and then we'll wrap up with some lessons learned. Now, throughout this presentation, I'm going to be referring back to mainly one project, and this is the River Oaks Commercial Center in Paso Robles. This is a LEED Gold certified building. It was the first pre-certified commercial building in San Luis Obispo County. And part of that LEED certification was about 30,000 square feet of pervious concrete, which was used in the parking stalls throughout their parking lot. Now, the reason why I'm referring to this particular project is twofold. The actual placement and construction of that pervious concrete went really well. And it's also been in the ground for about 4 years now. And so we can say with certainty that that is also a very durable product and it's holding up well to the traffic in that parking lot. So why do we use pervious concrete? The main difference between pervious and traditional is that it does allow stormwater to pass through the structural section. And so what pervious concrete can do is allow for groundwater recharge if you're in an area that infiltrates. It will certainly reduce runoff from your project site because you're capturing that rainfall where it lands. And what this can mean also is that you can reduce your traditional storm drain features on your site, such as area drains, valley gutters, and other typical features in a parking lot. Some of the advantages of pervious concrete, again, it's highly permeable, it's traffic rated, so unlike a lot of other LID features, you can use it in place of traditional impervious surfaces. It's easily tied to other systems, meaning that you can use that pervious concrete to infiltrate water and then move it to other places on your site. So you can retain water during the smaller storm events and you can convey that water to another, say, underground facility in a larger storm. It also really sells itself. And so also, unlike other LID features, it looks different. When you see a panel of pervious concrete, you know that it's something different. You know that it's not your traditional construction. Some of the disadvantages mainly is that right now it's still a specialty product. And so what that means is that there's not a lot of experience with design or construction, and that ends up resulting in the fact that pervious does cost more compared to your traditional concrete. Another main consideration for pervious is durability. And so with the pervious concrete, you don't have a smooth surface and you have potential for what's called raveling. And that's where the aggregates that are on that top layer of your pervious concrete can become detached. And in some cases, you can end up with a gravel parking lot where you paid for an expensive pervious concrete parking lot. So we'll talk about ways to prevent that and how your construction methods really affect that potential for raveling. A visual comparison to conventional concrete. So conventional concrete is a nice, smooth, compact surface. In comparison, pervious concrete has a large void content, and it also has a rougher appearance. The finished surface of conventional concrete is tight and uniform. It's something that we've all seen and experienced. There's many contractors that are qualified for this type of work, and they're experienced in the traditional testing methods, your slump test for your water-cement ratio, your air test for freeze-thaw, and your cylinder test for compressive strength. And it's consolidated with vibratory methods and flat work, usually screeds and floats. All of those are very different for pervious. Another major difference is that we are all familiar with the design and construction of traditional concrete. It's been used in countless places. It can be used for non-traditional shapes. You can use it for curvilinear, for curve returns. That's all very different when you're working with pervious. And of course, traditional concrete is very efficient at moving water, so our curb gutter and our sidewalk will take water and move it, typically to a storm drain. So in comes pervious concrete, which will solve that problem of moving water. You'll be retaining water as it falls on the site, and you can use it to replace in very traditional places where you would have standard concrete. And this is actually the block that's being passed around the room. So I apologize for those of you on the webinar, you're missing out on that tactile experience. But you can really see the benefit of pervious where it's taking that concentrated flow and it's now spreading it out over a large surface area as it's moving through that structure. So where do you use pervious concrete? Pervious concrete is really well suited for light traffic applications. So your parking stalls in a parking lot, any type of low volume residential streets. It's great for sidewalks, it's great for walkways. Another consideration is that it's a really good product to use adjacent to trees. So as an example, we have a project that we just finished up design in Paso where we were installing a new sidewalk adjacent to a mature oak tree. Well, we called out for pervious in that location because the pervious allows for the water and the air to reach that root zone of the tree itself. So it's really good for that use. I've also seen it used to replace a standard gutter. And so you can have a typical street section where you're directing water to the gutter. And now that water can actually infiltrate along the gutter and be moved, either stored there or moved to other retention areas on your site. So this is a typical layout for pervious concrete. This is a parking lot, and we have our standard asphalt section through the driveway portion. And then the panels themselves, the parking stalls, are made of pervious concrete. And between those two different materials, we have a standard concrete curb delineator. And the purpose of this curb is to protect the edges of the asphalt and that pervious concrete over time. And in the ideal condition, you'll have water sheet flowing from your impervious surfaces onto your pervious concrete. So it can handle the runoff that falls on it and some runoff from other sources. One thing that you definitely do not want to do is design your site such that you'll be collecting runoff from your landscape or other pervious areas, because that runoff can have debris and other sediment that may actually fill up those voids in your pervious concrete over time. Another consideration in terms of sources is you can grade your sidewalks to drain to your pervious panels. And in this case, we've tied our roof drains also back to that parking lot. So we're really capturing all of the on-site runoff through that parking lot itself. Talking about some of the characteristics of pervious concrete, it's a gap-graded concrete, meaning that you don't have a continuous range of aggregate sizes in your mix. And so traditionally, a pervious concrete mix will have no sand or maybe very little sand. And this provides for your high void content. So the removal of the sand from the mix, really where you see those voids in that airspace is where you would have your sand cement paste. And what that results in is a highly porous surface. So upwards of 5 gallons per minute per square foot. Now if you translate that into a rainfall intensity, that's 480 inches per hour. So that's far more than we would ever expect to receive in a storm, and that's a big part of the reason why you can also drain other impervious surfaces to your pervious concrete. So how we achieve this high void content is with a very low water-cement ratio. So your lower water-cement ratio will result in a higher compressive strength in your concrete mix. And with pervious concrete, we're typically in the range of 0.25 to 0.35 water cement. And what this results in is a very stiff mix, near zero slump, very different to work with compared to traditional concrete. We also would use different types of admixtures, and we'll go into those in detail when we talk about specs. And the end result is that with this pervious material, you have a point-on-point contact. So you are really counting on a small amount of cement paste between the points of your aggregates in order to hold this surface together. Starting at the subbase, you would typically have a porous subbase, and this is where you will actually store water. So the pervious concrete only moves that water through the surface, and then any storage is happening in that subbase. The finished surface is very different from traditional concrete. It's open, you can see the voids, and it's varied, meaning that it's not a nice, smooth surface. And it's very different in terms of how you are loading that concrete. So traditional concrete is loaded mainly in compression, and it's very strong in compression. Now with the pervious concrete, as you're driving over it, as you're turning your wheels in the parking lot, you are applying shear and tensile stress to those aggregates that are at the surface, and that's what's going to result in the raveling of your concrete over time. And so you need to really have a strong paste that's going to be able to hold those aggregates together. And all of these result in very non-traditional methods compared to standard concrete, which we'll go into, and also really the need for quality control throughout the entire process, meaning through design, selecting the correct mix, through construction, through placement, and curing. Quality control is very critical. So moving on to talk about construction methods for pervious concrete, we'll break it down into placement, curing, material testing considerations, and also inspection and acceptance of your final product. So this is a photo of a pervious concrete pour, and pervious concrete is poured very differently than traditional in that you'll be working with small surface areas incrementally throughout your job site. And so in this particular case, this is the River Oaks project where they were paving the parking stalls only. And right now what they've done is they've formed up every other parking stall. And so they will place literally one parking stall at a time. They'll go through and place in one day every other stall, come back the next day and pull those form boards, and then use the stalls that they had placed on the first day as their forms to go through and now fill in all of the other parking stalls. Pervious concrete, because of its very low water-cement ratio, has a very short working time. And this is one of the primary reasons why you work in small areas, is that really the placement, the finishing, and the curing are all happening at the same time. And what this requires is you have a crew where each person is dedicated to a task. And it's like an assembly line, but everybody is working together and it all happens very quickly. So in general, you have about 15 minutes to place and consolidate your pervious concrete. During hot weather, that can decrease to as little as 5 minutes. This is a very fast procedure, and you need to have everybody working efficiently and together in order to achieve that. Starting again at the subbase, just like traditional concrete, you want to make sure that your subbase is uniform and compact. A difference is that you may actually have a maximum compaction because you are counting on that subbase to provide storage for your infiltrated water. And a very important step is that you have to pre-wet your subbase, and you want to achieve what's called surface saturated dry. And what this means is every surface that's going to become in contact with that pervious concrete is thoroughly wet, but you have no standing water. And this is really critical, again, because of the low water-cement ratio of your mix. You don't want your dry subbase to start pulling the water out of your mix as you're placing it. It needs to be thoroughly wet. And what that requires is you need a dedicated water truck and at least one crew member, and his job is going to be to move ahead of the placement procession and make sure that all of your surfaces are pre-wet. In terms of placement, so again, it's a very stiff mix, and really you cannot pump this material like you would a standard concrete mix. It requires a chute delivery. And not only that, because it's so stiff, it's not going to flow. You need to have somebody working that chute and physically moving that material down to where it's going to be placed. In this particular job, it was the foreman who was working the chute, and so he was really at the heart of the job. As he was placing that concrete, he was directing all of his crew members around him in terms of what they should be doing, and so he's controlling the rate of the progress. The consolidation of pervious concrete is very different than traditional. You do not want to use vibratory methods. You want to work this material as little as possible because you want to maintain that void space in your mix. And so the typical method for consolidating pervious concrete is with a hydraulic roller screed. And the hydraulic roller screed is turning with the power of a hydraulic motor, and you have two crew, one on each side, that are physically pulling it along the length of your panel. And what you want to see as you're pulling that roller screed is that you're maintaining a wave of fresh material in front of that screed. And what that's telling you is that you have just enough material that you're not going to end up with any low spots or divots as you're working from one end of the panel to the next. You also have crew members who are working with rakes, and they are basically working with this material as minimal as possible, but they're just pre-leveling it before you roll across it with that roller screed. One thing to notice, and it's a little difficult to see in this picture, but your strike off for your screed is actually slightly higher than your finished surface elevation, typically between 1/4 to 3/8 of an inch. And this is accomplished with a steel strip that's placed along the top of your form boards. And so the purpose for this is that the finish consolidation is going to be done with a hand roller. So your roller screed comes across your panels, you pick up your screed, you pick up those two steel strips, and then you move on to the cross rolling, which is done in both directions to achieve your final smooth surface of your place panels. And this is another photo of what that looks like, the hand rolling for the final consolidation. So after consolidation comes curing. And curing is really the most critical process for your pervious concrete. And this is again because you're counting on that bond of paste between your aggregates to prevent raveling. So curing is the time when hydration occurs. And hydration is the chemical process between cement and water that will allow that mix to crystallize and form a solid. You have to have water available for hydration to occur. Starting out with a very low water-cement ratio, you're already putting yourself at risk that you may not fully hydrate your product. So it's very important during the curing process that water is always available and that you want to protect the water that's in your mix as you're placing it. And what's used for pervious concrete is plastic sheeting. So plastic sheeting is placed over the surface of your concrete to hold that water in throughout the entire curing process. And this is a picture of what that looks like after all the panels had been placed. Now, the curing may start immediately after consolidation. On a hot day, your working time again is significantly decreased, and so you may have a crew member that's immediately following your roller screed and protecting that material with plastic. The curing will require a minimum of 7 days. The plastic stays on that entire time, and you will likely need to wet the surface of your concrete at least once daily. Now, what you're looking at in this photo is straight down onto the plastic sheeting, and it looks like there's a lot of moisture there. And you think, wow, we're doing great. My concrete is nice and wet. But what happened in this case is it was a hot day, all of that water had evaporated, and it's sitting up against the underside of that plastic sheeting. And so what it requires is that on a daily basis, you pull up your plastic sheets, you add water, and you wet the surface, and you make sure that it stays wet during that entire 7 days. A couple considerations for placing pervious concrete. Again, very different than traditional concrete, and what it really requires is a well thought out process from start to finish. And so what's typically required for pervious concrete is what's called an execution plan that would be submitted prior to placement, where the contractor is going to outline exactly what his methods are, what his mix design is, who his crew members will be on site, and what each of their roles are going to be, what materials they'll need so that they have them on site, and if they have any subcontractors, who those might be as well. And some of the things that you need to consider in your execution plan are irregularly shaped areas. So what do we do if we have a panel that's too narrow for us to use our hydraulic roller screed? How are we going to consolidate that? And this also becomes a design issue, because in your design and your layout of your parking lot, you really want to try to avoid any type of irregular shapes. And so one of the things that you can see in this picture is that the curb return has already been poured with standard concrete. And so you end up with a nice straight edge for your pervious placement. Another consideration that's very different is that you don't want your crew walking on the mix as you're placing it. So in a standard pour, you put on your work boots, you walk through the mix, no problem. But what this does is, as those crew members are stepping on the mix, they're possibly creating low points that are going to have to be reworked after the roller screed comes through. The other thing that happens that you're not going to see is that by stepping on it, they could be pushing some of that paste down to the bottom of your panel. And so from a top view, it may look like you have a really great pervious surface, but the underside of your panel in that area could be a contiguous layer of paste that's preventing any of that water from actually reaching the subbase. Another consideration, particularly because you'll be placing this with the chute of your truck, is how are you going to maneuver your truck around the site? You may end up with some very tight turning points, and this also needs to be outlined in the execution plan in terms of how you are going to be able to quickly and efficiently move your truck from one panel to another. Another consideration is, what are you going to do if the truck is delayed? And so in this case, they were halfway through one panel and the next truck hadn't showed up on site yet. And so they started protecting that concrete right away with that plastic sheeting. And if it did start curing before the next truck, they would have to use some type of control joint. So something to think about and really include in your execution plan. Moving on to talk about inspection. One of the main differences in inspection is that, in general, a pervious concrete pour will require a test panel. And so during the process of the test panel is when you're going to be testing out your mix design, you'll be testing out your methods, you'll be testing out your curing. So that test panel would usually be required 30 days prior to your actual placement. And only after that test panel has been accepted by the engineer is when the contractor would then go back and write that all up into his execution plan. Just like traditional concrete, you're going to want to look at your dispatch slips, you're going to want to check your mix and make sure you have the right admixtures. But any water that's added on site, with each addition, it's important that you recalculate your water-cement ratio. Again, the water-cement ratio is very critical to achieving the strength and that bond between the aggregates, and so it needs to be followed closely in the field. In addition, your inspectors should be checking both temperature and wind speed. So both of those factors affect your curing and how much evaporation you can expect from your surface. So if you think about the surface of pervious concrete, it has a significantly greater surface area compared to standard concrete. Wind can move through your panel. it can come up from underneath your subbase and start to evaporate that water in your mix. And so you really want to control and monitor well, you can't control the temperature, but you want to monitor the temperature and the wind speed so that you can control your curing process accordingly. In terms of your field verification, again, very different than traditional concrete. So to check the proportions of your mix, you can use a standard unit density test, but the slump test doesn't apply. You have a near zero slump, so how do you check consistency? You use what's called the ball in hand method. And this is physically where you're going to take a handful of that pervious concrete, and you should see that it wants to clump together and form a ball. That means that you have a nice thick paste and good contact between your aggregates. You should also be able to toss this ball up in the air and catch it again, and it should maintain its shape or maybe break into 2, maximum 3 pieces. You want to see that it's holding together. What the top picture is showing is a mix that's already started to hydrate. It's very dry. It's not held together by a paste. And what you're seeing on the bottom is a mix that's too wet. And so your thin paste and your aggregates are starting to segregate. And what you're looking for, that Goldilocks, is right in the middle photo to where you have a nice thick paste that's holding those aggregates together. And a close-up of what that looks like, you're looking for a sheen. You're looking to see that that paste is still wet, that hydration has not started to occur, and that each of those aggregates has a nice thick coating that's going to bond them together during consolidation. Material testing, again, is very different. Your conventional tests typically do not apply to pervious concrete. Some of the things that you can do to test your material after placement is a permeability test. So the reason why we're using this material is to infiltrate stormwater. So you can call out for a volume or a rate of water to be infiltrated over time to check the infield permeability of your material. You can also take core samples, and core samples would be used to make sure that you did achieve curing and hydration throughout the entire depth of your panel, that it didn't just cure on the top, that it cured down to the bottom. You don't want raveling on the bottom any more than you want raveling on the top, because then you're degrading your structural section. Now, if your cores show some issues, or if you are having raveling occur, you can do what's called a petrographic analysis, and this is certainly more in depth. It's a laboratory-based analysis where you can actually go back and check the hydration of your concrete and try to determine if it was a curing issue that caused the raveling. So with all of these specialty methods of placement, there are contractor certifications that are available for this material, and those certifications are provided through the National Ready Mix Concrete Association, and these certifications are a combination of coursework and time in the field. So the highest level of certification is a craftsman, and this would typically be the foreman on your job who's directing others to do the work. And then in terms of field crew, the different levels of installer and technician are again based on the hours of field experience. Now you can look up and see who you have in your area who may be a qualified installer on the NRMCA database. So that's that link on the bottom, is to find out how many contractors you have available in your area with that type of certification. And inspectors can be certified through the NRMCA as well. So moving on to talk about specifications. The main difference between traditional and pervious concrete is that traditional concrete specs are usually performance-based. And right now, pervious concrete specs are typically prescriptive. So a performance-based spec for traditional concrete may say that you need to achieve 3,000 psi and you'll have a tolerance in terms of your elevations. And it's up to the contractor to figure out the mix and the methods to make that happen. With pervious concrete, you are literally calling out the mix design. You're calling out the admixtures. You're calling out the methods. You're calling out how to cure the material. And what that does is it's really placing more liability on the owner and on the designer to know that what they're calling out for is really the best method for construction. So there certainly is more liability, and it also means that you need somebody who has experience in this process in order to write a spec that's going to result in a good product. Now your specs may call out for different certifications for your installers, and keep in mind that you may be right away limiting yourself in terms of the number of local contractors who can bid on that portion of the work. You may be requiring contractors to come in from out of the area. Your specs will call out for a test panel when that needs to be placed, and one of the things that we did on the River Oaks project is we had what we called our engineer test panel. And so the contractor placed and consolidated 2 panels, and we were responsible for the curing for one of those panels so that we can compare the curing process between both after that 7 days. Your specs will call out for the submittal of an execution plan. And if you're in a location where you could expect both hot and cold weather, you may need 2 different plans for those conditions. And your specs will call out, again, your mix design with any admixtures. In terms of admixtures, there are a few that are typically used in pervious concrete. A hydration stabilizer will extend your working time. So this is really to the benefit of the contractor, that you'll have some more time to work with the material before you start that curing process. And the second is a bonding agent. And what that bonding agent does is it acts like a glue. So bonding agent is typically used to physically work old concrete with fresh concrete and bond them together. And when it's used as an admixture, it can increase the strength of that paste and increase the point-on-point contact of that bond between your aggregates. And self-consolidating admixtures can increase the viscosity of your paste so that you're better able to get a nice coating around each of the aggregates. And they can also control segregation so that you don't have that paste and aggregate separating. Another consideration for pervious is fiber reinforcement. So fiber reinforcement has been used in traditional concrete for a number of years. And what research has shown that it can do for pervious is it can strengthen that bond between the aggregates, because now you're counting on not just the paste, but you may have a contiguous fiber connecting one aggregate to another. Now what research has also shown is that during construction, those fibers may have a tendency to catch some of that concrete paste and reduce your void ratio. What it can also do over time is also catch sediment and debris that may have passed through previously. And so both of those things can lead to reduced permeability. So you really need to weigh the benefit of the strength to the addition of, or excuse me, to the potential for possibly reducing your permeability. Some resources for preparing specs. Both the American Concrete Institute and Caltrans do have standard specifications. One thing to keep in mind is that these are not off-the-shelf specs. So these will need to be tailored to your specific job site, and they require a lot of decisions to be made in terms of, will I require a test panel? What admixtures will I add? So you can't just take this spec and hand it to a contractor. You will need to modify it. And for whatever reason, the Caltrans spec and the design guidance is kind of difficult to find, which is why I put that path up there. So the path will show you how you can navigate to that from the Caltrans website. Or if you want to search, make sure you search for pervious pavement, and then you should be able to find that document. So moving on to some lessons learned about working with pervious concrete. Number one is don't walk on the mix. I said it before and I'll say it again, that it was a very difficult thing for us because the crew members are so used to being able to walk on the mix. And so in order to prevent this from happening, what you really need to do is control the rate of the concrete coming out of the chute so that you have just enough material that all the crew can reach it with their rakes, and that they don't need to be walking on it in order to pre-level before that hydraulic roller screed. Another lesson is, again, related back to the very low water cement ratio, is that you really want to minimize the time it takes to get your concrete from the truck to the ground. Again, recommended is chute delivery. What we did see on another project is the contractor used a conveyor belt so that they were not having to move their truck, and they were transporting that material from the truck to these various panels on a belt. Well, that finished product ended up having some raveling problems, and we think that what happened is that the hydration started to occur, the material started to cure as it was traveling along that conveyor belt, because it just extended the time that it was exposed to the wind and the temperature before you were able to start the curing process. Another important consideration is to anchor your plastic sheeting. And so again, it's the increased surface area of the pervious concrete that's going to allow water to evaporate much more quickly. And that air can come in, wind can come in, not just from the top or the sides, but also from the bottom. So that wind can travel through your subbase, and it can travel through your panel, and it can result in billowing of your plastic if it's not properly anchored. And so the plastic is going to do you no good unless you have it anchored in place. Another lesson learned, and this was in particular to panels that were not fully placed while we were waiting for the second truck, was to think about reducing the length of your riser strips. And so again, the riser strips are those steel strips sitting along the top of your form boards. And the purpose of those strips, again, is to elevate that roller screed above your finished surface elevation, because your final consolidation is by hand. Now, what happened in this case is we were waiting for the second truck to come on site. And what really needed to happen is that the concrete that had been placed needed to be hand rolled. And it couldn't be adequately hand rolled because those riser strips were still preventing the rollers from getting a nice smooth finish along the edge. And so in this case, the ideal situation would be, if you knew that you were getting towards the end of the truck, maybe you start using half-length riser strips so that we could have pulled that back one off and continued working that concrete that had already been placed. Another lesson learned is that because this is such a dry mix, it was really difficult to add water on site. And so it's common in a traditional concrete pour to hold back water at the plant and to add water as you need it for workability. Well, because this mix was so dry, when we did add water on site, you could hear the water sloshing around the outside of the drum and the mix just rolling on the inside. It took many more revolutions, a lot more time to incorporate that water into the mix than it would traditionally. And so as the job progressed, what the contractor ended up doing was holding back less water at the plant and coming really close to that target water-cement ratio to reduce that additional amount of working time trying to incorporate water on the site. Also related to the very stiff mix is that it rides differently in the truck. It has a higher center of gravity. So this is an experienced concrete truck driver who happened to take a turn like he normally would, and that high center of gravity just caused that truck to turn right over. So again, it's a very different material in all ways compared to traditional concrete. Another lesson learned, and Pat touched on this quite a bit, is construction sequencing. So oftentimes these pervious panels will go in pretty early in the job because of the time for curing. So you need that 7-day curing, and ideally you want 28 days before you have any vehicle traffic on these panels. Well, if they are placed early on the job site, you need to consider how are you going to move your equipment around. Again, in your execution plan, you need to consider how is your truck going to actually access each of these panels, and you also need to protect that pervious concrete once it's been placed. So for example, on another job, the pervious concrete was placed, it was fully cured, they came back and poured and worked all the asphalt, all the flat work was done, the contractor pulled up the sheeting, in comes the landscape contractor who then stockpiled all of his materials on that pervious concrete. And so right away, the contractor was then responsible for coming back and vacuuming out, which is one of the maintenance measures for pervious, vacuuming out and restoring that pervious concrete. So you want to protect these surfaces just as if they are a storm drain inlet. And I'm going to wrap up on one other consideration, and I'll call it lessons learned, is that there are other surfaces and other materials that will perform very similar to pervious concrete. And one of the reasons why I'm bringing this up is because we recently just had a project go out to bid where we had very similar area square footages of both pervious concrete and pervious pavers, and the unit price for both of those came back to be almost identical. So if you're paying the same price for concrete versus pavers, you really need to consider the advantages and disadvantages of both. So the pavers take out all of the question about your mix design and your placement and your curing, but they also have their own disadvantages that you could have some differential settlement over time. They are backfilled with sand between the pavers themselves, so you may need some weed control, things that pervious concrete doesn't require. So you really just need to consider all of your options in terms of your pervious pavements, and there's plenty of opportunities for them to be used. This is a picture of a project in the city of Santa Barbara. So in the past few years, the city of Santa Barbara has repaved a number of their parking lots at their public parks using pervious pavers, and they used them in the parking stalls, very similar to the River Oaks project. So that is what I had for you today.